We had two almost equally rated talks about emotions, and they're both going to be full talks. And we didn't have enough time to fit in the schedule. So what we tried to do is we're going to squash the two talks into one. And so I'm going to talk for about 20 minutes. Mike's going to do about 20 minutes, and then Chris is going to do about 20 minutes. Or at least that is the plan. So why? That's the first question. Why humanoid robots? And in particular, why emotional humanoid robots? Let's start with humanoid robots. So people often say it's utility, right? You have a humanoid robot so it can do the same things a person can do. And to that I say, Roomba. You don't have peppers walking around holding vacuum cleaners. You have a box that's way cheaper and does one job really well. So you might think, okay, well, there's the DARPA Robotics Challenge, yeah? That's for humanoid robots in disaster situations, right? So that's the winning robot. It's called Shaft. It's really cool. But hands up, whoever has their arms attached to their hips. No. So I think, okay, we can demolish that one as well. No. The reason we have humanoid robots like now, the reason they're interesting right now, is the interface. And that is, we're trying to get the same interface as other people. Because if we can do that, well, people already know how to interact with other people. So if we can mimic enough of that with a robot, we have a user interface that should be understandable. So just to sort of step a bit backwards, we've had a few different user interface paradigms. We've had the command line. We've had WIMP, Windows icons, mouse pointer, the graphical interface that you all know and hate. We have mobile, which is basically WIMP twisted a bit. Virtual reality was pretty cool. Didn't catch on. One of the reasons being is that you could be in this big, nice environment, but you had to step out to the real world to do it and put these goggles on. And that's okay for gaming. It's not so okay for actual sort of business style applications. And in a past life, I used to work in virtual reality. And we had really cool apps, but people didn't want to use them because they had to strap things to your face. And now we have humans. So we're back to our interface paradigm that hopefully everyone knows anyway. The other cool thing about the human paradigm is it's naturally social. You have something embodied in the world. Unlike with virtual reality, you don't have to go in there and get it. It's already there. And it's already social because it's one thing interacting with another. So in theory, making it multi-user shouldn't be much of a step. And so you might be thinking, okay, are there people who can tell us how best to get humans to interact? And it turns out there are. There are people who study this. They're called sociologists and ethnomethodologists. Now, ethnomethodologists, try saying that when you're drunk, are basically, it's a branch of anthropology, and it studies how people work together. And the trouble with sociology really is that they have, if they say things in a way that uses ordinary language, you go, well, I know that, it's obvious. If they write it in an academic way, you go, huh? And so I really like this. It's actually an ethnomethodologist who produced this fake magazine cover, but I like it because they wrote impenetrably, and that's not so far from the truth. But the point is, there are a bunch of people who study this sort of thing who should be able to help social robotics developers if we go out and ask them. And there's been some really fascinating studies, for example, of how people work together. And it's not just speech. For example, there's a study of the London Underground where they found that although these people were notionally working completely independently, they structured the way they worked and the way they spoke and the way they moved so their colleagues were aware of what was going on. But if you asked them, did they do that? They wouldn't know. But if you watched them, you could find out. And so there's lots of interesting information there that I think we as robot developers could benefit from. So again, emotions. Why emotions? Who has a Roomba here? No one. Oh, okay. Do you talk to it? No. And you laugh. You think, hey, why would I talk to my Roomba? I think, as Mike was saying yesterday, people talk to now when it's turned off. You know, there is something about the humanoid form that makes us us make assumptions about it that you wouldn't make for a Roomba. And that has benefits and it has costs. The benefit is, shut up.
Hello, I'm Robbie. My internet
I shouldn't have done that.
192, 168,
Sorry.
43, 250.
Yeah.
I have updated dialogue underscore launcher.
Oh, I really shouldn't have done that.
Dialogue underscore lexicon. I have updated presentation. I have updated the dialogue.
Okay. So the benefit is that people will naturally incline to treat this robot in one way. The downside is that if you don't make account for emotions, your robot is still projecting emotions in people's minds. And there's basically a quote by a guy called Paul Ekman, who's an emotions researcher. And he said basically, if you look at your washing machine, you don't assume that has feelings, and so if it acts indifferent to you, you don't care, you don't expect it. But with a robot, if it acts indifferently, you don't think, oh, that's neutral. You think, the robot doesn't care about me. Yeah? So you have to do something to make the robot act in a sort of socially acceptable way. That's my justification about why I'm looking at this. So I'm now going to sort of change track a bit and talk about the work I've been doing on emotional models so far. And I think there's a certain number of things that the emotional model has to satisfy in order to be useful. And Christy may disagree with me, but we'll see later. I haven't seen his talk. But I think, people are complex things. You don't necessarily think one thing at once. You might express one thing at once, but you may be sad that your dog died, but happy to see your friend. And although your expression may change, internally, you haven't forgotten your dog has died. It's just something else temporarily overwhelming it. So you have different feelings that you have to sort of juggle at once. It should be able to learn. The robot should be able to learn, okay, these things I like, these things I don't like. And it needs to help with action selection. Because at the end of the day, you want this to change the way your robot behaves. If the model can't help you do that, then it's not really being very useful. So I think Christy mentioned Maslow's hierarchy of needs. And the idea being is there's certain motivations that need to be satisfied first. So if you can't breathe and you don't have food, then you don't really care if your self-esteem is low. And the reason I mention that is that in this particular model, motivations are structured in that way. They have a certain priority. So I can say, okay, battery level on the robot equates to hunger. And if his battery's about to die, then that's kind of more important than being friendly. So you need to account for that. So in my model, a motivation, it's a basic drive or desire, such as a need for food, safety, company, personal development. And these are sort of naturally structured in some sort of precedence level. So I'm going to say that really it's a collection of motivations that give rise to sort of perceived emotional states, and that some may be dominant at any given time. And that each motivation works pretty much independently. And the goal really is to achieve homeostasis. So if everything is satisfied, the robot is happy. I don't need to do anything. My battery is full. My friends are here. I feel like I'm doing something useful. I'm in a good place. But if something diverts away from that, if he's by himself or his battery's low, that's the time he needs to do something. And so that's when the motivation starts to give him his behavior a nudge. Now, each motivation, I'm calling a thing called a percept, basically. A percept is something the robot can perceive. So it may be internal, it may be battery level, it may be external, it may be it's seen a face, it's recognised a person. It may be proprioceptive, so it knows it's moved its arm. All that is basically, called a percept in my model. It's something the robot can sense. And likewise, each motivation can trigger a series of actions. Now, so I'm going to be really quick here. So, right, how does it work? So you have a world. You have a bunch of motivations, and as we said in the panel yesterday, these motivations, these emotions, might not be the same as human emotions. They could be robot emotions. So it's a set of things that make sense for the robot. You have an overall emotional state, which is the robot's state at a given time. You have a bunch of things that I've called recognizers, and these are things that can sense something about the world or something about the robot state. And they translate that into percepts, which are things that the motivations can understand. And basically, all percepts go to all motivations. I just haven't drawn that because it just gets too messy. But basically, the motivations, they receive everything, and it's up to them to decide what's relevant. Okay. The motivations feed into the current state of the model. And that then decides, okay, what do I do next? So you have two components here. You have a action component, but the action component also means that you're generating something else the robot can sense. It can sense that it's moved its arm. And so that, again, feeds back into the motivations. So doing something can satisfy a motivation. But I said learning. So it's not much good if the robot can't learn. So what this model does is it tracks things that it's recently perceived in short-term memory. And it tries to work out how its emotional state has changed while those percepts are in short-term memory. And after a certain amount of time, they'll get evicted from short-term memory, and the robot has to decide, did something interesting or significant happen to me while this thing was in my short-term memory? And if not, I can throw it away. It's not important. If it is, I need to remember that. Something about that was significant. And that then feeds back into the recognizers. So when I see something that's similar again, I can already give that some sort of emotional significance. So the emotional significance here can be based on pure calculation, or it can be a pure memory or a mixture of the two. So, I'm going to very quickly do a demo. But the things about demos is they often don't work. So in case things go horribly wrong, I'm going to very quickly show you what you should see, and then we'll see if you actually see it. So, you should see a model reacting to things it can perceive. You should see the robot deciding what to do based on its emotional state. And you should see percepts entering short-term memory. You won't see items from short-term memory going into long-term memory because this demo is going to be too short. So, I'm going to very quickly start up I have a web app that shows the robot's current emotional state. Because, hey, you want to see what's going in the mind of my robot. I'm sure you've often wondered that. Let me just start my demo. So, this is actually written in, I'm prototyping in Closure, which is a Lisp. And the idea is eventually, when I'm happy if the model works about right, I'll rewrite it in Python and actually run it directly on the robot. But right now, it's running on my laptop, and it will connect to the robot, if all goes well. Dum-dum-dum-dum. Yes. Oh, isn't it marvelous how things decide to compile when you... Okay, right, okay. Okay. Yay, I have a web server. Right. Right. So what you're seeing is a number of different things. These are sort of instantaneous values of each motivation. And further down the screen, I'm giving the actual data. There's nothing in short-term memory. And I faked... Oh, actually, I need to connect the robot first. Because lighting is really tricky and things like face recognition are really tricky, and because I couldn't get Steve Ballmer and Linus Torvalds to come here today, I decided to fake it. So basically, the idea is that clicking on one of these images tells the robot it's seen one of these faces. Let me just see if I can connect my robot.
I'm starting to feel quite emotional.
Well, that's a good start. So he's got various percepts. If I can tap, oops. Let me just scroll down so you can see things change. So he's getting bored because nothing much is happening. Let me just poke him a bit. Yep. So you saw those boxes there which came to sort of signal that he'd seen something. Yeah, touch. He's not bored because I'm touching him, but touching the back of the head is a bit scary. Let's see how he reacts to Steve Ballmer, because Steve Ballmer was pretty scary. I mean, whoa, I'd be scared. That's okay. Let's see. It's scary enough. Tap him back of the head. Yeah, okay. Steve Ballmer was fairly scary. Linus. I mean, he runs Linux. He should like Linus. Yeah. And let's give him a now robot as well. Okay, so he's actually relatively satisfied at the moment. He likes it now, and you can see in the short-term memory, he's tracking a bunch of things. So each one of these is a percept. It's tracking when he entered short-term memory, when it's going to leave, where it was, which currently fixed to home, and who else is involved. So agents is unknown, which shouldn't be really. This is basically the levels of each motivation when he saw it, and this tracks how the motivation changed while it's in short-term memory. And I'm running out of time, so I think I should really start handing over to Mike. So that was the kind of quick and abbreviated talk. Maybe while Mike's setting up, we can handle questions. Any questions?
How did you connect the web application to
Okay. It uses the Java API. So there's a project called Nausea, which is a closure binding for the Java API. So my application is written in Closure, and I use that. And yeah, what I want to do eventually is migrate the application to. Ooh, interesting.
Welcome. I'm bored.
Yeah, see, nothing much was happening. He gets bored, and now he's going to get turned off as well.
Nook, nook.
But yeah, eventually what I plan to do is rewrite the web interface so it uses the JavaScript API and talks to the direct to the application. Sorry.
What comes next for you in the development?
So what I didn't say is that the model so far is based. Well, it started out as an effort to understand someone else's model. There's a guy called Michael Sellers who wrote this emotional model for artificial agents. And I thought I understood it, but being a programmer, I thought, well, okay, I'm a developer. The way I really now understood something is I can build it. So I started building his emotional model in Closure. And there are things I don't agree with. So it's now no longer his model, it's some sort of combined model. And I have the way he handles precedence over motivations on a sort of stack level, I don't agree with. So I'm changing the way that works. And I forget that I have a long list of things that I meant to do before now, and I haven't, but it's gradually diverging. And I think Mike's ready, so I should shut up and go away. Yep, go on.
So how did you define the valence algorithm numbers? So was it using the satisfaction vector or some?
Yeah, so it basically uses satisfaction vector. So there's a sort of a mapping function that looks at the collection of satisfaction, the global satisfaction vector, and decides how it maps to arousal and valence.
Okay, my talk's going to be a little bit shorter than Dave's, as whilst we're a joint project, he's put in loads of effort so far, and I'm just still kind of at the thinking stage. Dave's talked a little bit about his emotional model based on Mike Seller's paper, which is based on valence and arousal. So he's very much looking at the internal state of the robot. I'm going to be looking at the external state of the robot, and how the robot actually expresses emotion physically. So just kind of in terms of the overall project breakdown, we have kind of notionally titled our piece of work AL Emotion, but and I kind of use that in some bits of my write-up. But so the idea is that there would be an emotional model. That was the bit that Dave's working on. There'd be some kind of recognition that's going on, and that's the kind of like the people perception that's handled by Aldebaran. There'd be developer-written applications, so a game or a storytelling application or whatever. And then we're sort of working on this middle layer that's going to excuse me. This middle layer that's going to fuse together excuse me. It's going to fuse together any motion or any outputs that are created by an application. It's going to take the emotional state from the model, and it's going to get the robot to physically express that emotion. So our project's kind of broken down into a transport that's kind of shifting all the data around in the robot. And then the bit that in particular I'm working on is the adapters. So those are the physical bits of the robot, so the eyes, the hands, the legs, the head, gaze perception, stuff like that, and then how that's physically expressed. So it is a framework that we're working on. So we want to be able to people to be able to add in their own emotional models if other people have written them, not just Dave's emotional model. There's other emotional models out there. The PAD model, pleasure, arousal and dominance. We've gone for a valence and arousal based model. But we want to make it more people to be able to plug in their own emotional models. Because we want to make it easy for developers to express emotion through their application. We don't want them to be having to sort of worry about, the robot expressing a particular emotion. We just want to make it a transparent process for them. So there's kind of a number of challenges which I identified to physically expressing emotion with now. We need to map these kind of nebulous values of valence and arousal to actual physical characteristics that a human would express, and then we've somehow got to map that human expression of emotion to now, as whilst now has some physical similarities to a human. He's got hands, he can do body language. He's got a face, but the face is kind of different. So he's got eyes. We rely on reading things like someone blinking, or eyes quite wide open, or position of the eyebrows, things like that. Now can't express any of that stuff through the face. And then there's unique aspects of now. So you can change eye colour. Most people can't change the colour of their eyes unless they're, the devil or something like that. So can we utilise that now? That somehow to express emotion through the robot, and more unique things. We had Greg's not here, but Greg was talking about Chuck yesterday, which is a music synthesis piece of software. Could we use the unique characteristics of a robot, its ability to make sound, for example, or to make music, to express emotion somehow? So that's the second challenge, is mapping our human emotions to now's specific physiology. And then we need to start to blend that into the to existing applications and the motion that they might be expressing. So I've done lots of reading on this area, and there's loads and loads of papers, there's loads and loads of research. Lola Canamero, who we heard from, has got some really interesting work that specifically it's used now, and sort of static poses, so the static body language of now. Dave mentioned Paul Ekman, he's got some really interesting stuff on positions of the face for particular emotions. Cynthia Brazil, very famous roboticist, lots to read about social robotics. Mike Sellers, who Dave mentioned, for the valence and arousal model that he's kind of basing some of his software on. And a book that I found particularly interesting, written by some guys at Disney, doing sort of very early animation, so having to really sort of distill down human characteristics, human emotional, expressive characteristics down into very simple characters. And that's kind of been as important to me as to how I'm going to get stuff to work with now, and for him to express emotion, as any of the more technical literature. So in order to simplify the problem, as humans we have got lots and lots and lots of emotions that we can express, and fine graduations in between each emotion. In order to get the project underway, we've decided to concentrate on the 6 most universal emotions that we express. So happiness, sadness, anger, fear, surprise and disgust. Another advantage of those is the universal emotions that are understood by all cultures and by all people almost sort of intuitively. They don't have to be learned. They're known from quite an early age. And again, sort of the work that was done by Disney sort of proves that you can express emotion quite convincingly by just concentrating on a small subset of the emotions. And from a software development point of view, that really simplifies the test and development process if we just concentrate on a few particular emotions. Testing, I'd like to test whatever we produce with a wide variety of users, and perhaps using some metrics: recognizability, repeatability, universality, believability. And as we've kind of seen and talked about a little bit with Now, we're slightly processor bound, and now we're kind of hitting the limits of what Now can actually calculate. And if we're starting to run quite complicated emotional models and animations and things, then we're going to be hitting the limits of the processor. So we need to be aware of writing decent code that can allow other applications to run. Is everyone familiar with kind of valence and arousal? Is it worth me explaining it? Okay. Do you? Okay. Okay. So essentially you can plot all emotions onto this graph, which is valence on the x-axis and arousal on the y-axis. So valence relates essentially to the degree of positivity or negativity of the emotion, and arousal is sort of how aroused, how animated you are with that particular emotion. So anger, for example, it's a very negative valence and also highly aroused. So you're like, really angry, like that. Whereas pleasure is it's quite a positive emotion and equally generally quite aroused as well. Dave spoke a little bit about Maslow's model. Have you implemented sort of layers in your?
I have, yes.
Yeah. So you can have multiple layers of valence and arousal as well that roughly correspond to Maslow's hierarchy as well. So kind of a simple summary of valence and arousal. It's taken from Mike Sellers' paper on how your face might express the the different levels of sort of positive valence and positive arousal, or negative valence and negative arousal. The one thing that I've found lacking with VA is some kind of degree of your stance when you're talking to people. Are you sort of leaning into them, sort of engaging with them, or are you sort of coming back in, like in fear, for example? So I'm having a bit of a think about the robot's stance as well. And that's kind of backed up by some of the work that Lola Canamero did with the Now, and Paul Ekman did with body language as well. And then in terms of mapping human emotions to Now, we've got lots of different variables that we can access in the API in NAOCONF. So I'm just going to concentrate on the LED part. So colour of the eyes, how intensely they're glowing, whether you're winking or blinking, whether the eyes are rotating. So blinking is quite a human thing that we can use to express emotion. Rotating eyes, again, most people can't do that, but could we use that, for example, to express some degree of emotion with Now?
Maybe bored. When he's bored, all his eyes.
Yeah, yeah. So just thinking about eye colour in particular as an example. How should we decide what colour Now's eyes are, say when he's happy or when he's sad? So initially I started thinking about maybe there's some cultural references that we can draw on. So red eyes for anger might be quite obvious. But what about sad eyes or surprised eyes? What colours should they be? And there is some information out there. There's a really cool book called Information is Beautiful, and it's kind of all sorts of data visualizations, and it's just plotting for different cultures what colour they associate with a particular emotion. So if you were plotting the colours for the eye colour on the valence and arousal graph, talked about being sort of red for anger, or sort of yellow for happiness. But there's a problem. If the robot is going from anger to sad, you might expect as you transition from the emotion of anger to the emotion of sadness, physically, if you mix the colours up, you would expect to get purple there when you're round about there. However, culturally, purple is actually kind of expressing surprise, so you can't actually properly mix the colours as you transition from one emotion to another. So rather than using cultural references, I wondered if you could use some artistic references in the term of the colour wheel. So anger there, happiness there. Might you be able to actually physically mix the colours? So again, that example that I talked about of progressing from anger, which is red eyes, to sadness, which might be purple eyes. And then you're getting sort of some kind of purpley colour of eye in there for fear. But I felt that didn't quite work because there's two kinds of colour wheel. There's an RGB colour wheel and the artist, and the artist one, which is red, yellow, and blue, which seems to work just a little bit better. No demo. And then, just some references.
Mike, is it worth saying?